Now, hi everyone, welcome back to the channel. Now in this video we're going to talk about reverse engineering and the current kind of state of 3D scanning in the market at a DIY level and on a professional engineering level, and how I made this carbon fibre down tube protector that weighs only 46 grams for my downhill bike, because the factory protection that came on that was absolutely crap and I had too many stone chips on the first weekend of riding it. So this is actually the second one of these I've made now because someone else has asked me to make one for their bike, and I thought it was about time we discussed how I made it and all the different advantages and disadvantages of 3D scanning, measuring by hand, measuring by calipers, and just reverse engineering in general. At the moment, there are 4 or 5 ways to reverse engineer components that you might want to build stuff for that you already have. So if you've already got a bike frame, or you've already got, I don't know, a laptop and you want to make a case for it, or a down tube protector for a bike or something like that, there's a number of different methods to reverse engineer a product towards something that will interface with that. Now the most basic of those methods is just by measuring it by hand. Take a set of calipers, a ruler, a pencil, some cardboard cutouts. But when you've got things with complex curvature like bike frames or car body panels and things like that that are just too complex to measure with calipers and rulers and pencils, you need to employ some other kind of methods to get close fitting interfaces around those parts. Now complex carbon molds and 3D shapes, measuring by hand just isn't enough. The other way of doing it is just to get the CAD of the model that you're working with. So if you are looking at designing a phone case or something, or a laptop case, you might be able to find that CAD online so you can build your model around that, and you've got the native 3D CAD ready to go that's probably quite accurate, that's been leaked from a factory or leaked from an employee at the company that develops those things. I don't have the CAD in this case. I don't have a Cube engineer to hand to call up and say, look, can you send me the 3D CAD for the Cube 219 downhill bike, or whatever it's called. So I'm going to explore 3D scanning. Now 3D scanning is a piece of technology that's been around for, I would say, 10-15 years now, but it hasn't moved on at the pace that 3D printing has. Now 3D printing has moved on at such a pace that you can get a really good at-home 3D printer for a couple of £100 or a couple hundred US with a very fine resolution of 0.1 millimeters, easily achievable or something like that. But 3D scanning has stayed in the realms of the professional engineers, and in this video we're going to look at the kind of home-based options of 3D scanning apart, and the professional options 3D scanning apart. And the most important thing about making this carbon protector is making the mold. This is actually the very, very last step, laying up the carbon, fixing on these adhesive pads, these Velcro pads to stick it up onto the down tube. That's the very, very last step. The most important thing is making a good mold, and making a good mold needs really good 3D geometry of the frame. Like I mentioned, a couple of ways to do it. Measurements. Well, I can measure the width of the down tube pretty easily. I can take the widest point across the down tube. I can make a couple of cardboard templates, and then you can kind of create like a skeleton, like you might do for a boat hull or a wing spar in a plane, with many different planes cut through it to create your 3D model. Now that's quite a laborious task to do that quite accurately. But for very simple shapes, simple tubes or rectangles or cubes, you can do that quite easily with a set of calipers. However, I really wanted to explore the 3D scanning. Is it going to help me do reverse engineering at home on bike components? And I think it's been quite fruitful doing this little project. So the first method of 3D scanning I want to talk about is kind of the stuff that you do using your phone. Now, there are a number of different apps out there. The one I've been using quite a lot is called Polycam. It seems to be quite good, and what that does is augment and stitch loads and loads of still images together to create a 3D model, and we're going to look at the accuracy of that. The second 3D scanning option I had is a professional level 3D scanner, and that requires the little reflective dots to be put all over the bike to get a good map, and the mesh of that is much, much finer, as we'll see, and we'll compare the two 3D models together and see how I made the final thing. Now, as you can see here, I've got another photo that's been scaled. As you can see, there's a massive stone chip on the down tube, and look at this, is the factory down tube protection that doesn't even cover the high stress points of the down tube. Now, the highest kind of stress concentrator, if you take an impact or something, is going to be in the corner, and why they didn't wrap this rubber protector around the corners, I don't know. The adhesive will just fail over time after a number of bike washes and hammering it all through winter. I don't expect that to last, and it was already peeling after a couple of weeks of riding. So point was to replace that. This is just another scaled photo with this yellow piece of tape on here scaled to size, so when I import that into the CAD I can scale it, and I'm just trying to build up a library of photos, scaled images, so I can take the 3D scanning, check that's correct, and hopefully to make this mold, it was going to be a hybrid of all different methodologies. The 3D scan from the Polycam app, so this is the kind of do-it-at-home DIY 3D scanner that just uses photos to stitch together to create a 3D image. Now, the results on this screen look quite good because they actually overlay the photo texture and the photo colors on top of the 3D file, and you can't actually see the kind of discrete mesh. So the results look quite good, and to do this off just photos is absolutely amazing. Now, the more photos you take, the better the mesh gets. You can select a finer mesh, you can select a coarser mesh. The finer mesh takes a lot longer to kind of render out. But overall, I was quite impressed. This was the first ever trial I'd had of scanning this down tube. I didn't really use a plain background, I just did it in the shed. So there's lots of other stuff and paraphernalia that the algorithm is blocking out. And the result from this alone, without any kind of markers put down or reference point stuck down on the frame, was really, really good. But what would it look like when we stuck it into CAD? Well, when we put it into CAD, it needs a lot of cleaning up. It's not a closed 3D model, it's not even a closed mesh. It comes in as an STL, and there's a lot of artifacts you need to clean up. And to do that manually is quite difficult. So I stick it in a program called MeshLab. Now, this is an open source software, and you can see here the down tube. I've actually clipped it at the top and the bottom where I don't need any of the other data. Now, you can clip this manually using the discrete mesh points, or you can kind of use an algorithmic based assumption to help close this mesh. And then when you want to bring this into as a solid model into your CAD package, because most CAD packages don't really work well with STLs, you need to have it closed. So if you want to do Boolean commands, subtracts, unions, you need to close the model and then turn it into a solid. And this is the principle behind this MeshLab. It's a mesh fixing program. You can refine the mesh, you can actually extrapolate points, you can actually make a coarser mesh than you have already, or you can make a finer mesh than you have already. Now you can see the detail it's picked up is there, the overall geometry is there, but the refinement of the mesh is pretty poor. It's very coarse. So this was a good first try, but once you measure across the 2 points of the down tube, the width and everything, that actually lines up pretty well with the hand measurements. But that is pretty good off a free app off a phone, I have to say. If you just want a general size of something and you're not looking for complete fidelity, that's not bad. Now, I could go back and do all these photos again and create a much finer mesh and get a better output than this, but this was literally just the first go of scanning this bike, and I was really happy with the results. Now, I'm obviously not going to make a very high fidelity 3D mold off of this, but what it does give me is a good opportunity to compare this against the really high level professional 3D scanning tool, which you can see here. This is in the tens and 20s of thousands of pounds worth of kit. So compare the photogrammetry mesh that we got from Polycam, which is the phone app, to the real professional level result. And you can see this, the fidelity of this mesh is so much finer. It's picked up the existing rubber down tube protector really well. It's picked up the text very well. The thing it struggles with is shiny surfaces. So on this Cube downhill bike, the Cube logo is in a gloss black, and it's really struggled to pick up those reflective surfaces if it's just left the mesh empty there. But that's not so much of a problem. All we need to do is know where these outer points are and somehow get a good visibility of curvature on the frame, and then we can go ahead and put the model on it, check the angles, and start to create the mold in CAD that I was going to 3D print and then lay up the carbon into. Now, if we compare the both of them side by side, we can actually see that the ultimate dimensions, or the absolute kind of geometry, is pretty much bang on between the two. The angles of the down tube are correct. The width is almost correct, apart from a little bit of flaring on the Polycam one, on the phone cam one here. But overall, it's not a bad result if you just want some, kind of basic dimensions without taking any measurements. And you can see here down towards the BB, the end of the down tube protector that has been scanned by both is pretty much in the same plane. Even though the Polycam one has got pretty lumpy results, the angles are all there and the absolute dimensions are pretty correct. So I was quite happy with that as a free result. Now, this grey part that I've just enabled here is actually the carbon shell. This is the finished carbon shell that I wanted to end up with. And these two pieces of CAD really kind of enabled me to make this to a very, very fine tolerance. Now, when this is installed on the bike, there is no gap between the edges of this and the down tube. It's flush fitting, it's almost perfect, and that's helped by doing the 3D scanning. Now, obviously, once I've created the actual shell, which I want to end up with, then I need to create a mold. So a simple offset and construction process was happened to create a mold. Obviously, my 3D printer at home isn't very big, so I printed it in 2 parts. This is how I join the mold together. I pin it together so I know that when I glue it, the alignment's all good. And if I put the other part of the mold on there, you can see that is then the mold assembled. And then if we show the original sketch of the bike in there, that's how it fits on the down tube. I've gone into other videos if you want to see how I do carbon layups on 3D printed parts. I've made 3D printed mud guards in a couple of other videos before, but it's actually quite rewarding when you get it right. And I've said this before, the only specialist parts you need to do this at home is a 3D printer, and even those can be picked up for £300–400 nowadays. All the carbon material that I've been using here is not pre-preg, it's nothing fancy. You don't need a special oven, you don't even need a vacuum pump. You just need a couple of closed storage bags and a Dyson, or just a handheld vacuum cleaner. And I've got very, very good compaction, very good resin distribution from a wet layup just by using closed vacuum bags. That's been the reverse engineering process. If you want to have a go with 3D scanning at home, try Polycam. It's a really, really good app. The more patient you are with it, the more light you can get into the photos, and the cleaner the background to the photos, the much better scan you're going to get. Like I said, this was done in the shed, and I didn't even put a white background down or anything. It was just crap all over the place, and it still did a really good job of picking up the down tube. The difficult bit, and this is what's always holding the industry back at the moment in terms of even just the professional level stuff, is getting that bare STL mesh with all the points into something that you can use and engineer from in a CAD package. That STL to step file transition is the bottleneck, and that has been for years, and it still is. And that's why I don't believe kind of at-home 3D scanning is taking off, because yes, you can spit out an STL, which is just a mesh model, but to get that into a useful state is quite difficult. And at the moment, most people are just drawing around these STLs and are actually using them to make engineering blocks or building blocks in the CAD package. So that's the current state of 3D scanning at home and at work on a professional level. Thanks to everyone who contributed for this video. Connor, massive thanks to you, and Easy Composites for supplying the composite product to experiment with this stuff. Cheers, and I'll see you in the next one.